All right, so this video is going to be for my AC Systems students. We're going to talk about converting from peak to peak, average, and effective voltage. Um, I've got some questions about that. So the four different voltage types that we have, like I just said out loud, are going to be peak to peak, peak to peak, peak, effective, which is RMS, and average. Okay. So our focal point, our center of the universe in this is peak voltage. All right. That is what we're going to do everything based off of. So peak to peak is the simplest of all of them. It is just going to be 2 times the peak value. So that's no big whoop. Our effective or RMS value, I can get 2 different ways. I'm going to show you 2 different ways to get RMS and average. So my RMS value or effective voltage value is going to be either the peak voltage times 0.707, which is the same thing as peak voltage times the sine of 45. Okay. In fact, we'll do this way. So those are the same values. And in fact, I'll punch it up on the calculator real quick. With my calculator, I can see that the sine of 45 is 0.7071, blah, blah, blah. So sine of 45 is going to get you a little more accurate, but 0.707 is going to do the whole can't see it from my house version. It'll be close enough. Average voltage is either the peak voltage times 0.637, which is the same as stating the peak value, 2 times the peak value divided by pi. So again, going back to the calculator, if I take 2 divided by pi, 2 divided by pi, where's my pi button? There it is. I get a value of 0.6366, which is 6.37. So multiply that value by peak. It's algebra, right? So we can memorize all those. And another thing that we got to be able to do, and I'll give you this example right now. If I take my fluke meter right here in my classroom or in your house, and I put the black prong into the neutral slot, and I put the red prong into the hot slot, I'm going to get 120 volts. And that is my effective voltage. So if I have where my effective voltage equals peak times, we'll just use the easy one, times 0.707, I know that my peak or my effective voltage is 120, so that equals peak times 0.707. I want to find my peak voltage. I'm going to scroll the screen up real quick, if I can. There we go. So I have to take, algebra says whatever I do to one side, I got to do the other. So I'm multiplying by 0.707, which means I got to divide by 0.707 on both sides. And when I do that, 120 divided by 0.707, let's go calculator. 120 divided by 0.707 gives me a value of 169.73. So we're just going to go ahead and call it 170. So 170 volts equals my peak voltage. All right. We are going to get to a point that I'm going to tell you guys to remember these 3 numbers. So here's one of the numbers I want you to memorize. Here's one of the other numbers I want you to memorize. And last but not least, now that I have a peak value, if I look back here again, I see that my average value equals peak times 0.637 or 2 peak over pi. For me, 2 peak over pi is a lot easier to use because I've already got a peak value. And lucky for me, that peak value is still in my calculator. So now that I've got that peak value of 169.73, I'm going to take my average equals 2 peak. All right, I don't know what's happening with my draw pad. Equals 2 times peak divided by pi. So with my calculator, being as it is already on there, peak value, there's my peak. I'm going to multiply that by 2 and divide it by my pi value. And that is going to give me a value of 108 volts. So my average voltage in this case equals 108 volts. And that is the other value that I want you to memorize. If you can, there's an easy way to do this if you're good with direct proportions and you can memorize those 3 numbers and where they go. Okay? So in this case, and that being said, we're going to take those values and we're going to say that my peak is 170. My effective equals 120. And my average equals 108. So if I can memorize those 3 values, I'm going to go ahead and skip all the way out of all the other calculations, everything like that. If you can memorize those 3 values, and that's where they fall, then we can just do this with direct proportion. So let's go ahead and take it. So instead of us converting from one value to another, let's take 277 volts of effective. So my E effective, I'll do this in green. My E effective equals 277 volts. So here's 277 volts is my effective voltage. And I want to solve for this 277 volts. I want to solve for that. What do we want to do? Average? Because I don't really have a conversion to go from effective to average. So I'm going to do effective, but I'm looking for average. So I'm going to take my effective voltage that I remember from before, my effective voltage. If I have 120 volts effective, I know that I've got 108 volts average. Because we know that because these proportions are always going to be the same. That's why I'm saying if we memorize those, we'll be okay. If I'm confusing you right now, stop the video and move on to something different. But if you could kind of understand that if I have effective, if I get given an effective value and I'm looking for an average, and I remember that 120 effective equals 108 average, you'll be fine. And you can do this directly proportional. So if we do that directly proportional, punch our calculator up again, and we got to cross multiply. So we're going to multiply 277 times 108, and we're going to now divide that by 120, and that gives us a value, an average value of 249.3. Average equals 249.3. All right, so that's we're going to check it. We're going to come back over here to our equations. And remember, I have an effective voltage of 277. And I want to convert that effective voltage to an average voltage. So I'm going to take my 277 effective. Actually, I'll bring it up here where I've got my formulas. So here's my formulas. In fact, I'll just bring it right down here to the very bottom of the screen. So I've got my peak value. It's peak to peak is just multiply peak times 2. We're not going to get too much wrapped up into that. So I have an effective voltage of 277. So 277, and I'm going to take that 277 effective equals peak times 0.707. Peak times 0.707, which means, again, that we got to divide both sides by 0.707. And so when I do that, 277 divided by 0.707, 277 divided by 0.707 gives me a peak value of 391.8. So we'll just write that 391.8. We're going to use the value in the calculator, though. 391.8 equals my peak value, because that's what we just solved for, peak. Now, if I want to do peak to peak, I'm just going to multiply that value by 2. And I'm going to do that right now anyway, because my average value, we can see right here, is 2 peak over pi. And since I've already got peak in the calculator, there's no reason. I could just multiply it by 0.637. But I'm going to actually take that value that's still in my calculator, peak, and I'm going to multiply it by 2. Again, if you want to just multiply it by 0.637, that's fine. I'm going to multiply that by 2 and divide it by my value of pi. And that is going to give me a value of 249.43. 249.43 volts average. I'll just do that, equal average. All right, so that 249.43 average, what did we get down here? Oh, look at that, 249.3. I know a lot of groups are really, really stressed out about rounding and all the other stuff. This is going to be just fine because the answers aren't going to be that close, and you're going to be close enough on that voltage value. Please feel free to contact me if you didn't get it, or if there's something else you feel like I could add to this. But other than that, this should wrap up how we do these calculations.